All right, today, as it says there, matrix multiplication. Okay, so matrix multiplication, a little bit different to normal multiplication. And so probably the easiest way to explain it is by doing some examples. So let's say if I have a couple of matrices, these ones I'm just going to make it 2 by 2 ones. And so here's A and B, 5, 1, 6 and 3. All right, so I'm going to do A times B. So as you would expect, the way that we would write that is like this. Right, and that's where the similarity between matrix multiplication and normal multiplication finishes. So with matrix multiplication, what we do is we follow this pattern. We go across the row and down the column. And you'll notice that there's 2 elements across that row and 2 elements down that column. Alright, so there's 2 elements there, 2 elements there. So what we do is we multiply this first by this 5, and then we multiply this 3 by this 6. Okay, and so, oops, I need to change my pen back to black. So, the 1 by the 5 and the 3 by the 6. And what we do with each of those is we add them together. And so that's the first row and the first column. And so you see that there's a row and a column, first row, first column. So then I just keep working with this first row and down any more columns. If there was more columns, I just go first row and so on. And I'll talk more about that as we go. So in this one, we go across that row and down this second column. So 1 by 3, so I'll do in green. So I'm going to go across that row and down that column. So I'm going 1 by 1. And onto that, I'm adding 3 by 3. Okay, 1 by 1 plus 3 by 3. Now, if there was more columns, another column, I would go row 1, column 3, row 1, column 4, and so on. And then I would keep getting more elements. So here, so row 1, column 1, row 1, column 2. And so you'll notice you've multiplied row 1 by column 2 to get row 1, column 2. All right. Then we move on to the next row. So now I'm going to cross row 2. Oops, thought I'd change that. I hadn't. Here we go. Cross row 2, down column 1. So row 2, column 1. Row 2, column 1. So that's where that's going to end up. All right, so 4 by 5, 2 by 6. So 4 by 5 plus 2 by 6. All right, so you notice these numbers are the same because they're the column 1 numbers, but these first numbers are different because they're the row numbers. All right, then the next one will be row 2, column 2. So 4 by 1 plus 2 by 3. 4 by 1 plus 2 by 3. All right. So what have we got there? Go over to the next page there. That's what I'll do. So as I do go over to the next page, I'll work out these things. So 1 by 5 is 5 plus 3 by 6, 18. So this is A times B, 5 plus 18. 1 by 1 plus 3 by 3, so 1 plus 9. 1 by 1 plus 3 by 3. Now this one, 4 5s are 20, plus 2 6s are 12. And then the last one, 4 by 1 is 4, plus 2 3s are 6. And now we just add those numbers together. 5 plus 18 should be 23, 10, 22, and 10. All right, so 22, 32. All right, so there's A times B. All right, so I'll do some more examples and point out some things on the way. So let's have a look in. So we've done A times B. How about we do B times A and have a look at that? So B is 5, 1, 6, and 3. And A is 1, 3, 4, and 2. So remember, we go row 1, we go row 1, column 1, row 1, column 1. So 5 times 1 plus 1 times 4. 5 times 1 plus 1 times 4. Then we go row 1, column 2. 5 times 3 plus 1 times 2. 5 times 3 plus 1 times 2. And there's no more columns, so we stop. Then we move to the second row. 6 times 1 plus 3 times 4. 6 times 1 plus 3 times 4. Second row, second column, 6 times 3 plus 3 times 2. Alright, so let's do those multiplications. First one, 5 times 1 is 5 plus 4. The next one here, 15 plus 2. Next one here, 6 plus 12. Next one here, 18 plus 6. And then when you add them up, you get 9, 17, 18, and 24 for that. Now, if you go back that last page and have a look at what AB is from the previous page, found that AB is 23, 10, 32, and 10. Whoops, I'll squish that down the bottom there a bit. Sorry about that. Let me squeeze there. So AB was equal to 23, 10, 32, and 10. All right, so when you compare AB and BA, you'll notice that they're not the same. So that's one of the things about matrix multiplication that we've got to know. So for matrix multiplication, matrix multiplication, AB, BA, but there's a big proviso, not necessarily. I think I spelt that wrong too. So you can fix it up. Got too many L's there. So not necessarily. And so in our example, AB was not equal to BA. All right. So for matrix multiplication, you can't assume, like normal multiplication with numbers, you can't assume that you can multiply in any order and get the same answer. All right, so matrix multiplication, its behavior is a bit different to normal multiplication. All right, so not necessarily, so not always. Should have used that in the first place. All right, so that's one thing about matrix multiplication. And so let's have a look at the next example that I'm going to look at here. And so this time I've got A equaling 2, 4, 3, and 8. And I've got B, and that equals 5 and 3. All right, so I'm going to do A times B. And so A times B, 2, 4, 3, 8. And B, 5, 3. And that's it, that's all good. So we follow the same row by column. So when we do that, you got 2 times 5 plus 4 times 3. And now that's no more columns. So done. Then we move to the next second row, first column. So 3 times 5 plus 8 times 3. So that's 10 plus 12 there, 15 plus 3 8's 24, and so you get 22 and 39. All right, so you'll notice that in this, what we started with over here was a 2 by 2 and a 2 by 1, and then what we've ended up with in the end down here is a 2 by 1. So 2 rows from this matrix, 1 column from this matrix. Now you notice here, and I'll point this out and I'll do it in more detail in a minute and I'll show you, those 2 numbers there are the same. So the number of columns in your first matrix, 2 columns, is equal to the number of rows in the second, and that's a requirement. And we'll have a look in a minute with this next example, because this next example, what I'm going to do is I'm going to do B times A with the same 2 matrices. And so B is 5 and 3, and A is 2 and 4 and 3 and 6. So if we follow, we say across the row and down the column. So that's okay. I can start with that because I can go 5 times 2. All right, no worries. 5 times 2 plus what? And now there's nothing here to multiply with this 3. All right, so in this case, B times A is not possible. So we don't know what we're doing here. All right, so in this case, BA, not possible. Now, let's have a look. B, and so here we go, B and A, and so looking at the dimensions, B is a 2 by 1, and A is a 2 by 2. So the key thing here is look at these numbers. These numbers are different. So that's why we can't multiply in this case. And so those two numbers there must be the same. Or we can't multiply. All right, so I'm just going to write that down. So to be able to multiply, the number of columns in the first must equal, oops, let's go back there, must equal number of rows in the second. All right, so if you can have an M by P matrix and a P by N matrix, as long as these two here are the same, then we can multiply it. The number of these other numbers that I've done with the M and the N, doesn't matter what they are. They can be whatever, but the key is for multiplying, those two have got to be the same. The number of columns in your first has got to equal your number of rows in your second. All right, so when that's the case, then you can multiply away to your heart's content. All right, so I think I've probably done enough examples there. So I will leave you to do it. So what we're up to now is exercise 7E, page 286. And so this is questions 6 and 7. And so you can do all of 6 and 7. All right, and so this is about multiplying. And that's some of the questions you'll be so sometimes they're not going to be able to, things are not going to be able to multiply, and that's okay. And you just write that you can't multiply, there's no solution for those. All right, and as always, if you need some help, make sure you ask.